Hello and welcome back. In the previous video, we converted the outputs to one-hot encoded vectors and split the data into training and validation sets. So in this video, we'll be moving on to the neural network part of the MNIST Digit Recognition Dataset. But before that, let us just explore the neural network structure that we will be using in this example. This is the input layer and this is the output layer, and these are the hidden layers. I'll be using two hidden layers in this example. So let us just explore this. Let's consider the input layer first. As we know that the images are made up of 784 pixels. So we will be giving in 784 values to the input layer. So as a result, I have considered or I have given 784 neurons for the input layer. Now let's take a look at the output layer. We are expecting one hot encoded vector of length 10. So that is why I have considered 10 neurons at the output layer. These are the hidden layers. I'm using two hidden layers in this example. The first hidden layer has 120 neurons. You can change the figure in case if you want, and the second hidden layer consists of 32 neurons. So I'm considering this neural network structure in this example. Now let us just convert this neural network structure into code, and we will be doing it for the input layer and output layer in this example. So let us start to code. So let us import the Tensorflow library first. Import So I imported the library Tensorflow STF, and I'll run this part of code. So as you can see, successfully imported the Tensorflow library. Now this is the same from the previous tutorial. Now these are the placeholders that I have created. Initially there will be no values for the input layer and the output layer. So I create empty variables, that is placeholders, for input layer and output layer. Placeholders do not have any values. They get values as a runtime, but they take two mandatory arguments, that is the data type and the shape. So X is the input layer. I am using X as the input layer. So I create a placeholder for it. I give it a data type of float32 and a shape of none by 784. The 784 is the number of neurons for the input layer, or we can consider the number of pixels of an image. The none, I have given the none value here because I do not know how many images in a single batch I will be transferring it to the input layer. Now I have given the optional argument, that is name. I'm naming it as input as it is the input layer. Now Y is the output layer. So I am creating a placeholder for it. I give it a data type of float32 and a shape of none by 10. And as you know, we are expecting a one hot encoded array of length 10. So I give it a value 10 here, and I give it an optional argument of name. Since it is an output layer, I name it as output. So we explored the neural network structure that we will be using in the MNIST dataset, and we created placeholders for the input layer and output layer for our neural network. In the next video, we will create the hidden layer of our neural network. So I hope you like the video. Please click on the like button and subscribe to my channel. Thanks a lot for watching.